Hello and welcome to this webinar. We're going to be talking about demystifying Wi-Fi integration. Simple steps for adding Wi-Fi with robust IF performance. Today's speakers, the first one, this is me, Finn Boetius. I'm a product marketing engineer here at Nordic. And with me today, I have Jordi Miro. He's product engineering manager at Ignion. Very briefly, our agenda for today. I'm going to start you off with a quick Nordic overview. We're going to go into Wi-Fi and the NRF70 series, in case you're not familiar with it. I will have a section on synergy between protocols. And this is one of the reasons why we wanted to make this webinar, because in a lot of the cases where you're going to use a Wi-Fi antenna, you want to use more than just Wi-Fi. Then we're going to go into adding an antenna for Wi-Fi into a Bluetooth LE or thread device, adding an antenna for Wi-Fi into a cellular device, optimizing for cost, space, and performance, the new Wi-Fi antenna design guide, and then we're going to close it off with closing remarks and the Q&A. So the very brief overview of our NRF70 series. The NRF70 series is a series of Wi-Fi companion ICs. So it's going to be an extra IC that's going to be sitting next to a host processor. I'll talk here about the superset, which is the NRF7002. That's a dual band capable Wi-Fi companion IC. It's low power and secure. We've taken great care to ensure optimal coexistence with other protocols like Bluetooth Low Energy or Thread, for example. Everything's supported in NRF Connect SDK, and it's Wi-Fi 6 certified. In our case, we certified one of the development kits, which is this one. That's the NRF7002DK. And as you can see, you have different options of development kits that you can use. The NRF7002DK is a full-fledged development kit. It has an Arduino form factor. And this has the NRF5340 as a host MCU. That's this one. And then we added an NRF7002 next to it to add Wi-Fi capabilities. And we split the antennas. So you have here, you have the antenna that's being used by the 5340. And oh, my mouse disappeared. Yeah. And here, this is the antenna that we're using for 2.4 and 5 GHz Wi-Fi. We also have the NRF7002 expansion board. That actually has been launched. Oh, no. Excuse me. That will be launched tomorrow. So yeah, if you wait one day, you can order them. This is actually meant to be an expansion board that you can plug into your Thingy 53 to add Wi-Fi capabilities to it. And I think Jordi is going to talk a bit more about this in his session. But here we have one antenna for the for Wi-Fi, and by this design you can see that it's the Ignion antennas. And then we have the NRF7002EK, the evaluation kit. That's in the form factor of an Arduino Shield, so you can add it on top of one of our other development kits. The general idea here is if you want to use the 7000 or the NA of the 70 series devices with the 52 or with the 91 series, you would go for this evaluation kit and add it to a 9160DK, for example, or a 52840DK. And all of these kits can be used to emulate different NRF70 series devices. So I've mostly been talking about the 7002, which is the dual band IC, but we also have the 7001, which is single band, and then we have the NRF7000, which is a dedicated IC for Wi-Fi scanning. Okay, and now let's go a bit into why you actually want Wi-Fi together with other protocols. So if you look at Wi-Fi and our multi-protocol SoCs, a lot of the time you'll have the NRF70 series sitting next to a 52 or 53 series device. And it's relatively obvious if you want to add Wi-Fi to a Bluetooth device, you get higher throughput, so you can send more data that you want to. we have the QSPI as a host interface, which is really fast. And you can also use SPI, for example, but then the throughput is limited by the SPI. You get, on average, a slightly higher range than on Bluetooth. I mean, obviously, you can get kilometers of range on Bluetooth if you're going to do it right, but like the average BLE connection is going to be a bit less range than the average Wi-Fi connection. And you can improve the security a bit by using WPA3. And there's things like personal and enterprise support, and you can have encrypted QSPI for host data transfer. The other way, or another synergy between protocols would be Wi-Fi and Cellular IoT. This has two main use cases. There's probably more, but the two that I'm thinking about at the moment. One of them is an asset tracking use case where you can use or you can scan for Wi-Fi networks and send that data to the cloud and thereby use that information to figure out where you are. That's basically how your phones get your location most of the time. So they're not necessarily using GPS. They're most of the time using a database that's going to tell you where you are based on Wi-Fi networks that are close by. This is also a lot less but uses a lot less power than using GPS. Or another use case could be just offloading. So if you usually use a cellular connection to send your data, and then at some point your device comes home, you can use the home Wi-Fi or like the Wi-Fi of your device's home where you have actually access to send the data via Wi-Fi. So you don't have to use your cellular connection. All of this is integrated into our NIF Cloud and cloud location services. And yeah, Wi-Fi is a really nice complement to GPS in general. I made an extra webinar about this. If you're interested, you can check it out on Unleashing Wi-Fi Locationing. You'll find it on webinars.nordicsemi.com. And yes, so then let's have a look at the antenna design options. Or this is also the reason why we actually started the webinar, because there's some frequently asked questions when it comes to antenna design. One of the really first ones is when in my projects do I need to think about antenna design? It's the same as with security. At the start, it's kind of hard to change it afterwards because you will need to design your PCB in a way that it works well with the antenna. Can I design Bluetooth LE and Wi-Fi in the same antenna? We're gonna go into this in the Ignion part, but the short answer is yes. And then some of the other questions we're gonna go into is how can I optimize my design for PCB space or for performance or for the bill of material cost or even for things like design complexity. And with these questions in mind, I think I'm gonna hand it over to Jordi, and we're gonna go straight into basically these questions.
Hi everyone, and thank you, Finn, for your words. Let me briefly introduce myself. This is Jordi Miró, Product Marketing Manager at Ignion, and today in this webinar, as Finn said, we will see the design guide for Wi-Fi antenna integration and how to unlock the potential of Wi-Fi capabilities thanks to the Ignion Virtual Antenna technology together with the Nordic Semiconductor solutions. Nordic Semiconductor and Ignion has been partnering for so long. We share the vision of make IoT devices easier than ever. We aim we focus on making the RF part easy, and this is also thanks to the Ignion Virtual Antenna technology, which is an easy-to-use antenna solution delivering the first time right. We will see how we do that in the following slides. It's a market-leading flexibility. Ignion has a very reduced antenna portfolio, from a family of 6 products that are able to cover from 400 MHz up to 10.6 gigas. Of course, can be multiband and multiprotocol. So in your device, there can be different wireless protocols in just one component within your device. Ensuring always best RF performance, which means a long range and also taking care of the battery life of your device. Here we can see some of the devices that Nordic Semiconductor and Ignion has been working on this year. As well, Finn really explained all the capabilities that these devices have, but let me briefly explain the antenna part for each of them. We have the one in the left, the NRF7002 expansion board, which is using a duo MX10 providing Wi-Fi dual band capabilities in a very reduced PCB that is providing this through a dongle USB. The one in the middle also is using the duo MX10 in a bigger PCB, but this particular case can be assembled in different development kits, which means, and we will see it in one of the last slides of this presentation, that for each of them you reach antenna performance for each of the cases. And last but not least, we have the cellular device, and we will see also how Ignion Virtual Antenna technology is able to implement in this small form factor Wi-Fi dual band capabilities in a device that already has implemented LTE Narrowband IoT, cellular, and GNSS. But first of all, let me give you some context about the Ignion solution. Ignion solution consists in two elements. We have the hardware part, which consists in the virtual antenna technology. Let me use a pointer for that. We have the virtual antenna technology, which consists in three main elements. We have the red part number, as I briefly explained in the slide before, which from a family of 6 products, there are all non-resonant antennas, which means that can be tuned for any desired frequency range, thanks to the matching network circuit. This is a series of lumped components that can be inductors or capacitors or 0 ohms resistors for any short you may need to use. And once you have the antenna response tuned to the desired frequency range, that can be Wi-Fi single band, we will see in the next slide, can be also Wi-Fi dual band, thanks to once the antenna impedance is tuned, thanks to the ground plane. Then, that is the main radiation element of the system, how the Ignion solution, the virtual antenna system, provides optimized RF performance, for your device. But with this very simple architecture for your antenna integration, you may think that, okay, but for me it's complex. Okay, this then comes to the second part of the Ignion solution, which is the software part. The Antenna Intelligence Cloud design tool that, in tandem with the virtual antenna technology, the Antenna Intelligence Cloud ensures your design gets on the right path from the beginning. Basically, only by introducing the dimensions of your device and the frequency range you need to cover. Also, you can choose the antenna part number, but in case you don't know which one do you need or which one is the best fit for you, the system will choose for you the best performing option. So it's a free of charge service, so you can choose all of them if you want. It's a free of charge service, and you will get the report within minutes, up to 24 hours. And in this report, gathered in this report, you will receive antenna location, clearance area or the space for the antenna, let's say, the matching network, both with topologies and bill of materials, and also, as you can see in the graph here, you will receive the S11, reflection coefficient, PSWR, whatever you want to call it, and also total efficiency for the the total efficiency for your input that you put in the system, no? That you fill out in the form. So in this tandem, we as Ignion, the virtual antenna technology, we are able to provide easier than ever your first feasibility and your first step to make your device ready for the market. So to summarize all of them, all of the topics that I explained before in one of the devices from Nordic, we have The virtual antenna component that I said is the 2OM10 providing Wi-Fi dual band, tuned to Wi-Fi dual band thanks to the matching network, a series of inductors and capacitors, and then optimized and having enhanced RF performance thanks to the whole ground plane of the device. This is the virtual antenna system. Then, once we know all of this, okay, let's jump to how to get from the very beginning to the final prototype your device ready to the market. So Ignion offers the simplified virtual antenna design journey, which consists in step 1, feasibility. Okay, you can use the Antenna Intelligence Cloud. As I said, you will receive all the sorry, I forgot to mention that you will receive the design files for all the design recommendations that we provide. Get it in the report. You will receive the design files, so you will be able to start with some design CAD file and not start from the scratch. So once you have the feasibility analysis and you are okay with the result, you want to step to the to make a step forward for the design stage. We have the Gerber check that for all of the steps of the Gerber designing the Gerber or making the Gerber file, Ignion offers a free of charge service to review the Gerber and basically for ensuring that all the design recommendations has been followed to ensure optimized RF performance. And then once the Gerber is done, is following all the design recommendations, we step to the prototype part. And also here, Ignion offers a matching network service that typically from simulations to prototyping, there are always slight changes that makes the antenna response maybe gets shifted to the desired frequency range. So Ignion offers a matching network fine-tuning and also test materials in proximity in case your device is deployed in some walls, containers, metallic walls, and so on. So basically, this is the design journey that Ignion recommends to follow in order to get your device ready to the market as soon as possible, of course. So starting from the beginning, we will see for the NRF7002 expansion board, the dongle USB, the small one, we introduce the inputs in the Antenna Intelligence Cloud tool, and we receive the information that you are seeing. This is part of the information that you will receive, but basically with the device dimensions and the frequency band, we will get the PCB with the clearance area, with the part number recommended, as well as with the feeding line dimensions and the matching network topology. We can see here, we introduce the device dimensions from the final device. You will get the topology and also get it in this report, and it's not included in the slide, but it is in the report, the bill of materials, the components that we use, that the system use for the solution, for the solution, exactly. And here we can see the estimation of the performance in terms of total efficiency and S11 in dBs. And here is the link to test the tool. As I said, it's a free of charge service, so I invite you to test the tool because it's free. Then, once you are okay with the design, let's step forward to the Gerber review. I mean, this one. And once we make sure that all the steps, all the design recommendations has been followed, and we typically recommend these do's and don'ts, which is typically ensuring the proper clearance area, ensuring the proper space for the antenna with copper free. We also take care of the PCB size because the bigger the ground plane, typically the best the performance. We will see in one of the next slides how this impact on the performance. Also, always the transmission line must be 50 ohms to avoid mismatches in the antenna impedance that will incur in some losses in the system, so will impact in the antenna performance. And the part of the DONS, we typically and we strongly recommend not to put parts over or under the antenna. So respecting volumetrically the clearance for the antenna, the clearance area. Nervy components that are bigger, for example, batteries. I don't know. Typically, components that are nearby the clearance area, we typically recommend to keep away from the antenna part. This is not a must, but a recommendation. And of course, for the RF part, for the matching network, for the transmission line, the via grounding. The grounding for the RF part is live. So as part of the DONS, an improper via stitching will jeopardize the antenna performance of your device. So once all the design recommendations has been applied on the Gerber, once the Gerber is okay, we jump to the prototype. Okay, on the prototype part, here in this slide we can see a comparison between the simulation. In the simulation there are all the elements that are in the final device. So in terms of accuracy, is as accurate as possible, considering that typically when you manufacture between simulations and measurements, there are always differences, okay? Because in the simulation world everything is perfect, and in the reality, no. Here we can see a comparison between simulation and measurements in terms of reflection coefficient in dBs. There's one. Both in simulation for the black trace and in measurement for the red trace. You can see there are difference in the antenna response, but this is mainly caused because of the difference between manufacturing and simulating. Okay, but we can see in the total efficiency that there are similar performance between both simulations and manufacturing prototype. So we can see that following the design recommendations, even following all the design recommendations, the simulations will be always better, but it will ensure that the performance for your device will be as optimal as possible. Of course, for the final prototype, Nordic Semiconductor and Ignion working in an extended feasibility. Ignion offers these services to help you make the right choice to optimize the performance. So we can see here one of the feasibility analysis that we typically do for for choosing the design parts of your device, for the PCB dimensions, because it's not always a matter of best performing solution. There are typical space constraints, there are typically cost constraints. So that's why we did this exercise with these 4 examples. For the Duo MX10, the one that I explained before, and the Nano MX10 is the smallest antenna component we have in our portfolio, in 2 different PCB sizes, a 40 millimeters by 14 and a 40 millimeters by 24, so a wider PCB. And here we can see the comparison in reflection coefficient, in S11 in dBs, and in total efficiency. In this case, for this particular case, Nordic Semiconductor and also Ignion recommends the Duo MX10 for the 40 millimeters by 14 millimeters PCB size. Okay, so to summarize all of the steps that we previously explained, there are 2 ways to proceed in terms of antenna integration. You can go for the optimized antenna impedance, which means a good battery life, a reliable communication, and a longer range, taking care always of the battery life. And here we can see how the antenna impedance is perfectly, or almost perfectly tuned to the desired frequency range, which means all the injected power through the module, it converts to radiated power. So basically, there are no reflected power going back to the module, which means the efficiency is perfect to save the batteries. and also ensuring reliable communications. And you have the other way to proceed, that is basically can happen by doesn't following the design recommendations without using the intelligence cloud tool to get this first step, ensuring you are doing the design, the right choice for your design. It's the suboptimal antenna impedance, which means the antenna response is absolutely a disaster. It's not even close to a matching, not even close to the desired frequency range that you want to cover, which means all the injected power through the module, by the module, is reflected to the module, which means that this additional overheat, it means that you will have reduced battery life, because the module will try to increase the power, because they need more power to ensure the data communications. This additional overheat to ensure data communication will reduce the battery life. You will have poor quality of communication, and you can even damage your chipset. So basically, with all the steps that we previously explained, you will be in the right path to have an optimized antenna impedance for your device. And then, as explained before, those are one of the examples that Nordic Semiconductor and Ignion has been working on. In this case, providing Wi-Fi connectivity, integrating the Duo MX10 in an Arduino Shield form factor. Here is where we'll show how this Arduino is compatible with different boards, the NRF 52840 development kit, the NRF 5340 DK, or the NRF 9160 DK. So in the next slide, we can see how for each of the cases that the NRF 7002 evaluation kit, the one at the top of the slide, is assembled in different evaluation boards. These development kits or evaluation kits, they have different PCB sizes, different ground plane layers, which means the antenna impedance can change. Okay, the antenna response change for each of the cases, but thanks to the tailored capabilities of the virtual antenna technology, each of the cases can be tuned through the matching network, ensuring optimized antenna performance. And one of the cases that I briefly explained at the beginning of the presentation is a very small form factor delivering LTM/narrowband IoT through the bigger antenna part, the Trio MX10, and GNSS thanks to the Duo MX10. Here is where we implement Wi-Fi dual band capabilities thanks to this tiny antenna here, the Nano MX10. Here we can see a bigger zoom in. And thanks to the Nano MX10, the smallest virtual antenna component that we have in our portfolio, how we provide Wi-Fi, here is Wi-Fi dual band capabilities, is the green trace in both bands of the Wi-Fi dual band range. Of course, this solution it's a single antenna solution that also delivers PLE capabilities as well as Wi-Fi 5G. And this is it. This has been everything from my side. This has been how to easily get started with Nordic Semiconductor and Ignion implementing Wi-Fi capabilities to your device. And if you want to know more, we did a full document that is the new Wi-Fi design guide that is available from today. And you can download it by scanning the QR code here in this slide or by clicking in the website link below. And gated in this document, we will see the same step-by-step virtual antenna design journey, and we will see how to start your device from the very beginning of the design journey, starting by simulations with the Intelligence Cloud tool, how to jump from single band dual band, or to work with different protocols with the same building prototypes that we explained in that Finn and I explained in the last slides, including lab measurements, how to go from the beginning to the final device, also with analysis on PCB size, antenna component, space facing the space constraints, and so on. So if you want to know more, I invite you to download the document and also test the Antenna Intelligence Cloud tool that you can also access through the landing page. This is everything from my side, and let's jump to the questions, I think. Finn, I think it's your turn. Thank you.
Yeah, good. And we have gotten some questions. So let me, yeah, here we are. Hello. So let's start off with the questions. I think the first one is one I can take. So from the datasheet of the NRF7002 Wi-Fi chip, it is required to connect 3-wire the coexistence control pins for the host that contains Bluetooth. Why is that required? Because Wi-Fi itself can operate in an atmosphere where other Bluetooth devices may be working. In that case, could that create interference? So in general, what you want to do is you want to coordinate between the Wi-Fi and the Bluetooth LE channels. But also one thing to keep in mind is when it comes to regulatory certifications, you have to make sure that Bluetooth and Wi-Fi radio are not transmitting at the same time. Like there is some cases where you actually need to have this. But then again, if you have an IC or a PCB where the Bluetooth antenna and the Wi-Fi antenna, like if you have two antennas, when they're a couple of centimeters away from one another and they have mostly overlapping frequencies, you will not be able to receive any Bluetooth signals while the Wi-Fi antenna is sending out. It's just way too much output power. So, easy answer, regulatory certification needs, but also it's technically a lot better if you're not using them at the same time. Okay, next one. Let's take this one. That's something for Jordi, I think.
Okay, I'm a maker hobbyist. If I want to have an antenna design report, do I have to use company email to get it? I don't know, have a company. No, it's not needed. You can use the Antenna Intelligence Cloud tool in our website. I think that we can do a demonstration after the question part. And it's that simple and to fill out the form with your needs, and that's it, or reach the info mail that I think it's also that you will receive an email after you using the platform, the Antenna Intelligence Cloud tool. So you will have the support of our technical team. So it doesn't matter if you don't have a company email.
Okay. Next one. This is for me again. This is the question I answer every time. Yes, we will share the presentations and the slides from both sessions. So usually what we do is after we do the webinar, we take the recordings because we always have two sessions, morning session, and for us it's morning and evening. It's Europe and US basically. And we'll put those together, upload that, and with that on-demand webinar, I'll also put in the presentations that we use today. So yes, you will get it. Sometimes we download it live, but in this case, since it's two presentation, it doesn't work well with our webinar tool because we can just upload one file. Yeah, so this one's done. Then this one's probably for Jordi again. Looking at the Smith chart for impedance matching, how can I know where my initial impedance is placed so that I can design a matching network?
Okay, I don't know if you check out one of the slides before that there are some coaxial cables connected through a SMI connector in the board. So this is how we get I mean, I'm talking in the real world. I mean, in the lab, measuring in the lab. Okay. So we can just do this setup in the board of the PCB, connecting through the matching network. So we test the initial impedance of the antenna. So we just directly connect the coaxial cable in the first path of the matching network, and then we test the initial impedance of the antenna. So we can start tuning the antenna response. Or you can just apply the matching network that it is provided in the Antenna Intelligence Cloud report and start from that. So I think this is the answer, yeah.
Yeah, maybe one addition from my side. We some time ago we had a cooperation project with a YouTuber that basically does PCB design, and they have about a 90-minute session on PCB antennas, like the actual hardware design. I can really highly recommend that one if you want to get more information on that. And they're actually like going into like how to physically do the tuning and how it's different from PCB and chip antennas. I posted the link in chat if you want that. And if you're watching the recording afterwards, I'll also put the link in the description. Good. So next question. So this one's answered. Why doesn't it show? Okay. How do you tune when the board is in a housing and for a wearable in close proximity to the antenna?
How do you do when the board is in a housing? I mean, in a casing, right?
I'm guessing it's like a product case. Like, let's say you have a smartwatch, right? You want the antenna to like not be pointing in your body.
Yeah. Okay. Well, this is part of the services that Ignion offers. Once you have the final device, we test. We fine tune the antenna response in the end case. I mean, in the environment that your device will be deployed. It can be, as I said, a concrete wall, a metallic wall, a wearable, which means the human body will have an impact in the antenna impedance. So all of this is considered in our service. So you can just address to the Ignion services or the technical team. That you will be in contact once you fill out the form, or directly reach out to us through mail. And there are a lot of services that takes care of this kind of situations. For example, the human body, there are specific fine-tune for the matching network, and of course the housing is always considered in the matching network service. Yes.
Okay. Then this is more questions for you. What testing equipment is required for testing the performance of an antenna prototype?
Okay. Well, you can go for a simplified way to do that, which means you will need a VNA, a virtual network analyzer, so you can test the S11 or the S. The S parameters for in case you have multiple antennas in your solution, and then you will need an echoic chamber to test the antenna performance for the far fields, which means gain, directivity, antenna efficiency. For cellular cases, TRP, TIS, for example, or the other Wi-Fi performance results, but basically. The first way, more simplified, VNA, a virtual network analyzer, and the comprehensive way to do that is with an echoic chamber. Also, in Ignion, in our facilities, we have an echoic chamber, so you can just reach out to us to get your solution with a full report with all of these results for the antenna performance.
Okay. Also, again, the same video that I just posted in chat actually shows the tool on the table that you, or that at least our devs on tech support is using. So I, again, highly recommend that one.
Sorry, and there are virtual network analyzers that are portable. I mean, very cost efficient, let's say. They're very small and portable, or there are like bigger ones to the lab. So there are a lot of options to fine-tune the antenna impedance of your device.
Yeah. And then I think we mostly answered this question already. It's like we have seen how the antenna is tuned for certain PCB dimension, but how can the influence of metallic constructions in the immediate vicinity be taken into account? I'm guessing this is similar to the case where you're like, okay, I have a case where my smart device is sitting in, but also like if you're designing a device that sits on the outside of a wall that is metallic, you can probably also take that into account.
Yes. And well, I don't know if he's referring to simulations, but you can go to electromagnetic simulations in a full device way, taking into account all the elements, or as we do here with our customers, we just can take into account every single element of the environment of your device when will this device be deployed, both in simulations and real measurements. So in all the cases, we assess the performance of your device with each of the elements that you need to consider. So it's no problem.
Good. Then this is one more question, but it's more about hardware design. Some devices in tight space constraint use spring contacts to connect the antenna, for example, smartwatches. How well do spring contacts perform in comparison to WFL connectors?
Well, for it's every time it is the same. We have a lot of customers with different devices. So the last one, I think it was a smartwatch that the antenna plus the feeding line was connected through a certain connector. I cannot recall the name of the connector. Maybe it was a spring one or WFL. I cannot recall exactly, but was one of very different from what we have seen before. And the antenna impedance was tuned the same way and the customer was very happy with the performance. So every time it's the same. The matching network face all the challenges that your device will face in the deployment. So no problem.
Good. Then this is a question for me that I can't directly answer. So when can we expect a standalone Wi-Fi SoC from Nordic that contains Wi-Fi and the host processor? If you watch our webinar regularly, you're used to us not answering roadmap questions. Today I did the slight change to that because we have a launch tomorrow with the expansion board for the thingy. But questions like this, if something like this is planned, the only way we will ever talk about it is if you talk directly to a Nordic sales and you have an NDA in place. So this we can't answer any questions like this in a webinar. But it's good to see that there's interest, and if you're interested, talk to your local sales person. Then this is Jordi again. Does the design service cover other types of antennas, for example, iridium, when using Nordic NRF products?
You mean our services? If covers other type of antennas?
Yeah, I think they mean your antenna intelligence cloud.
No, actually, it's for current portfolio from the 6 product portfolio for the 6 virtual antenna components, and doesn't include other type of antennas or other technologies.
Yeah. In general, if you have a DevZone ticket, we also obviously deal with other antennas. But in general, usually what you want to do in most cases, or what we see customers doing, is taking a reference design or a development kit that Nordic is using and basically going with those antennas. And the antennas that we use for the EK and the EB, for example, and the new thingy, those are Ignion antennas. So that's just easier to go for it in this case. Okay, now this one. Do you support simulation results for non-rectangular PCBs, either circular or arbitrary polygons?
Yes, in the Antenna Intelligence Cloud tool that we will show you after the questions, it is include circular PCBs, and in the roadmap there will be included other arbitrary polygons. In case do you have any particular shape that is not included in the AIC, in the Intelligence Cloud tool, you can just reach out to us and say, I would like to have a simulations with this. You can share the Gerber, you can share some CAD files, and we will simulate exactly the shape you need to simulate with all the design constraints for your device. But
Okay.
yes, it is in the roadmap of the tool to have arbitrary polygonal shapes.
Maybe a quick addition from my side, like what if somebody has a flexible PCB?
Oh, flexible PCB, it's something hard to include, I would say. But it's not, it's different because it's typically they are rectangular, and the flex PCB is just the material. So I don't know if this will be included. Maybe I will need to ask that. But for the flex PCB, we can simulate it from our technical team. I mean manually, because it's a matter of a different material that can be included in the simulation characteristics. So can be they have parametric there are parameters specified for the flex PCB, so they can be simulated. So it's no problem for that. For the tool, for the cloud tool, it's different, and I will need to ask that because I don't really know, but I think it's not included now.
Okay. And then, hello there. Thanks for the presentation. Are there specific rules for via switching in designs, since it is reported in don'ts list?
Well, yes. From the technical perspective, sorry, we follow lambda by 10 from the PCB, which means is a matter of frequency. The more frequency you will you go up in frequency, you will need less spacing between wires stitching. And we follow for the RF part, the transmission line, the matching network, and so on, lambda by 20. So we ensure that the grounding is ensured all over the PCB. But for the other non-RF parts of the PCB, it does not need that amount of small spacing between vias. With a lambda by 10 is enough.
Okay. Then next one. Can you please share radiation characteristics of the designs that you have presented?
Oh, I don't have it prepared, but maybe you can reach out to us through mail. In the Intelligence Cloud tool, the report doesn't include radiation patterns, but all of our documentation in our website, all the application notes, you can just check for the Wi-Fi part, because we have like three or four antennas and virtual antenna components in our portfolio with application notes for Wi-Fi 6E included. And there you will see radiation patterns, gain, and so on. So you can just check out our documentation.
Yeah, so I think what we can do is, if you send it to me, I'll include it in the downloads and the on-demand session.
Okay.
Good. Then, how many decibel loss would you expect with an unmatched antenna, just dropping the matching networks? Oh, dropping the matching networks completely. Is it really that many? It's like what would happen if you didn't have a matching network?
So the question is meaning like compare with a matched antenna.
Yeah, I think the question is like, how big is the difference between just adding an antenna versus also doing the matching network?
The difference can be as I mean, it can be from 1 dB or 2 to 10. It depends of the situation, depends of the device, because all the PCB shapes and ground planes are different, so the antenna response will be different. If you have just if you put like random components, random inductors and capacitors values in your matching network, it can be even close to an open circuit. So this is like 0% of antenna efficiency. But let's say in a realistic way, when you have optimized antenna performance, like the perfect one, the perfect matching antenna impedance, compared with some, let's say, correct antenna impedance, you can have close to 3 dB of losses. But this is for all of the cheap antenna solutions that needs a matching network, or even the ones that are resonant, that you need, for example, a PCB tray or something like that. You always need to assess the impedance, the antenna impedance of your solution, because you can have a 0 performance antenna, or you can just randomly be lucky enough to have 80% or 90% or 100% of antenna efficiency. So it depends a lot of the situation.
Yeah. And I mean, worst case, you will actually like damage the chipset if you mess something up with the antenna network. But in most cases, it'll work. It'll just not be the best performance. And like if you only know 2 meters of range, I mean, yes, it probably works, but it's not recommended. And you'll also empty your battery faster if you like have to listen more.
Yeah. Typically, sorry, I would like to include something. Typically, if you include, for example, if you have, if you fill out the form of the antenna intelligence cloud, and then you have, let's say, a rectangular PCB, 100 by 50 millimeters PCB, and you follow the design recommendations, the bill of materials for this matching network should provide the correct antenna impedance to have good performance enough to go to the market. Will not be the optimized one, the perfect one for the real case, but it will ensure that you will have communications.
Okay, we have 3 more questions to go. So in terms of S parameters, is S21 or S12 important? Graphs only ever show S11 and S22.
Yes, this is for multi-antenna solutions, which means you have two radio protocols in your device. And S21 or S12 is the same, is symmetrical for 2 antenna solutions. It provides the coupling impact between antennas, which means if this value is so big, it can jeopardize absolutely the antenna response for you. Typically won't have, you won't be able to communicate properly. Let's say you have LTE plus GNSS or two Wi-Fi antenna, MIMO system. If you have very big coupling, which means a very high result for S21, the antenna performance of your device will be drastically dropped. So this is why from the very beginning, the cloud tool, the antenna intelligence cloud tool, also includes S21 results for the case of having multi antennas in your device. So if you fill out the form and you include 2 antennas, 2 radio protocols, you will have results for the S21. And also for the rest of the design journey with our services, let's say with the Gerber review, with the matching network services, and then or the electromagnetic simulations, the extra feasibility analysis, always the coupling effects are included, and we consider it to absolutely reduce the impact.
Okay, then for a complex solution, can Ignion predict a fairly good performance?
Well, this is very related to the previous question. Yes, from all the steps of the design journey for the virtual antenna design journey, Ignion always not predict, but make sure that the coupling effects, the antenna performance is always the best. So from the simulation part, you cannot assess exactly the antenna performance of the real device because there are a lot of components. Even the copper thickness affects the antenna performance. So you will have the full potential of your antenna. Let's say you have 90% of antenna efficiency in the simulation part. It means that the potential of your device is 90% of antenna efficiency. From that, and once you go to the end device, you will have 90 or less. So yes, for all the design journey, for all the even complex, it doesn't matter if it is simple design or complex design. We always we always take care of the performance in each of the stages.
Yeah, and like from personal experience of having been part of several projects where like you consider antenna design, you have some things that you just can't predict beforehand. So if let's say you make a design, you order a PCB, and then it's a lot different than from what you expected. It can even be different if you order the same PCB from two different PCB manufacturers. So you always need to, like, at the end, you need to check the actual hardware that you're getting. So it's not, yeah, it's not easily predictable. Okay, then the last question, we arrived. Is coupling between antennas being considered in your cloud tool?
Yes, it's the same. It's the S21 or the S31, let's say, for multiple antennas. Yes, the coupling is considered.
Okay, and we initially had the plan if we run out of time, or if we don't run out of time, we'll check the cloud tool. But since we only have 2 more minutes, I think we'll probably end the webinar here. And do the next webinar in 8 hours, I think. Well, this evening for us.
Yeah.
And if we have a bit more time there, then we can actually show the tool again, and you'll be able to see it in the on-demand webinar later on.
Okay, well, it's in the Ignion.io website, top right corner, free antenna design tool. Just click there and test the tool. Is free of charge, so I invite you to use it as many times as you want.
Okay, that sounds good. With that, Jordi, thank you very much for joining me today. And all of our viewers, thanks for joining us. And see you in the next webinar.
See you guys.
Bye.
Bye. Thank you.
Okay. So let's actually start off with one of the questions that we didn't get in this morning session because we ran out of time. So maybe, Jordi, do you remember we wanted to go, like, have a look at the tool itself, if we can just have a quick view of how it looks like if you actually want to use the tool.
Yes, sure, absolutely. Let me share my screen. Just go into the Ignion website, ignion.io. Do you see my screen?
Oh, wait, now everybody should see it.
Okay, so basically this is the Ignion website, the main page, Ignion.io, and here at the top of the right corner, you have free antenna design tool. Okay, so you have access to the free digital twin tool. So you click here and below, and then let's, for example, fill out the same example we show in the slides. Single band for Wi-Fi. Let's see, there are a lot of communication standard here gathered in the fill-out form. Let's see, Wi-Fi. You can just select the frequency range for your device. Can be single band from 2.4, 5G, or single band. Oh, okay. And then here you can just pick up one of the. You can choose one of the 6 of our product portfolio of the virtual antenna components. Let's pick up the Nano Extend, which is the smallest one. So if this choice is not matched with the best performing solution, depending on the system database, you will get 2 reports. So we will see it once we finish with this explanation. But basically, if you choose one of the antennas, for example, an anom extend, which is not the best optimized antenna solutions in terms of performance, which means antenna efficiency, you will get in the email 2 reports, your selection and the recommended one, separated from each other, and also design files from each of the both selection, your selection, and the recommended one. So the design files are a DXF file, which is basically a standard of a CAD file. Then we can add more communication standard up to 3 or even 4. I think it's 4, yes, within the same device. So you can just select the rest of them. Okay, LT, you can just MBIT, and also do the same here and start adding more and more and more up to 4, and then put the PCB length for your device. In this case, it was 40 millimeters by 14 for the NRF 7002 expansion board, the smallest one, which was a dongle USB, and let's say as a tracking and logistics for the industry, and also some forms related to your project, your name, corporate mail, company, role, and so on. Okay, it's 1 minute. And then click on submit antenna design request, and then, well, accepting, of course, terms of service, and then clicking on submit antenna design request, it should appear a page. So I strongly recommend you to wait until this page come up to say, congrats, you are 1 step closer to your final device. And then we can see what you will get. Let's stop sharing the screen and sharing the PCB files. Window, yes. Okay, so you will now see the PCB, the PDF.
Yeah, we are seeing a PDF.
Okay, so this one is for my selection, but let's say you choose an antenna that is not the recommended one for the best performing solution. So you will get the report with dimensions and so on, and the nanom extend, okay, which is the smallest one. You will receive the PCB as per your device requirements, the clearance area for the antenna with the feeding line, and the let me zoom out a little bit. Okay. And the topology for the solution with the bill of materials used for the performance estimation. Okay, here is more information about it. And if you want to know more about this antenna, you will have here the data sheet. Okay, the next one will be the slide for the overall performance in terms of total efficiency and S11 in dBs, and a table with summarized results for the performance in terms of total efficiency. Here are some general design recommendations for clearance area, antenna locations, materials used for the housings and enclosures, and some additional design recommendations for your design. Okay, and this is it. In case you have some specific applications, for example, a smart meter, you will receive additional design recommendations for this segment. So in case you don't select one of the applications that have special design recommendations, your report will be like this. And then it comes up the recommended report that is the same, okay, same results, but with the best performing solution. As you can see, the clearance is a bit bigger, and it's not the nanom extend, which is the smallest one, is the dual extend, the antenna that we have seen in the previous slide. Also gathered in the report, in the mail that you will receive with these attachments. Also, you will receive the design files with the DXF, which basically will be this top layer solution with the antenna layout, the feeding line, and the topology of the matching network.
Okay, perfect. Thank you. And then if you have more questions, keep them coming. We have some that we can go through. Start at the bottom. Most interested in the Wi-Fi sniffing and your geolocation service, can you please provide the link to this specific webinar? This is something that I mentioned in this morning's webinar. Let me just I put this in chat. So it's going to be at the same place where you will also find the recording of this webinar. So if you go to webinars.nordicsemi.com, you can go to the top, click on demand, and you will find our older webinars. You can also find them on YouTube if you want to. In general, if you just Google our webinar, you will find the correct video. That's how I sometimes look for them. No, but yeah, they're usually relatively easy to find. And there you will also find the slides. So by Friday, this webinar should also be in the same place. Good. Then next question. If you have a complex design, how confident is Ignion they can get a good performance?
Okay. It doesn't matter if you have a simple or complex design. It is from the first step using the Antenna Intelligence Cloud tool. You can just assess the performance of your device. Doesn't matter if it's a complex or simple device. The tool actually can face round PCBs and rectangular PCBs, and in the future we'll have some random shapes, such as, I don't know, the ones under your imagination. And the way we do that is through the design journey that I mentioned before in the slides, basically following the design recommendations and in the Gerber review before manufacturing. Also, you can use your electromagnetic simulation software to assess the performance before manufacturing with all the elements. This is the way we do, but this is the way we recommend to do in your as a do-it-yourself project, or you can just reach out to us, because we have services for simulations with full device, including all the elements in the final device, and also for the prototyping part, we have matching network services and assessing the performance with the final deployment, which means including metallic walls, concrete walls, body impact, for example, for the case of the wearables. But from your perspective, you can use your own electromagnetic simulation to do that, to include all the elements before manufacturing, so you can just assess the performance and ensures that your device is fulfilling the target performance that you have for your device.
Okay. Okay, next one. Do antennas support several HF signals simultaneously? Or do different RF transmitters need to transmit one by one?
Okay, this is a question that it depends. It depends of the use case. So, for example, for a Wi-Fi plus BLE, you can use a single antenna. It also depends of the requirements of the solution, of the use case. If you need high performance, for example, for the 5G, maybe it's recommended to use a separated antenna for 5G and for the 2.4 gigas. For the case of the single antenna, there are the front-end chipsets that use a duplexer to more or less simultaneously work. And in the other case, you can use a separated antenna to use high frequency signals simultaneously. But I think this is more in the RF part related to the chipsets and the more than the antenna part, because the antenna part meets the requirements as per the other hardware parts or the chipset part.
Yeah. And if you, for example, look at how we do the NF 7002, one of the things in between the host processor and the NF 70 series IC, depending on which one it is, there's always a coax interface. So you're not like using the antenna at the exact same time, but you can like switch really fast between them. That's basically the same thing that we're doing if you want to do multi-protocol thread plus Bluetooth Low Energy, for example. There you'll in basically every case use the same antenna, and you can do them concurrently, but you still have a dedicated Bluetooth signal and then a dedicated thread signal. So it is happening at the same time, but it's not like both signals physically at the same time. So it's
Exactly.
still multiplexed. Okay. Then the next one. If I have several different antennas in my design, does your tool take coupling between antennas into account?
Yes, the tool includes the multi antenna. It was a pity in the demonstration I did include several antennas, but yes, in case you fill the form with some multiple antennas in the same device, within the same device, you will have a separated slide for the coupling effect, which means the S21 or wherever the S parameters for that. And we recommend in all the stages of your device, because this is a feasibility analysis, this is the first step. Once you have, for example, simulations including the full device, all the elements in the full device, or even the environment, the surrounding area, always consider the coupling impacts in all the stages, even in the prototyping. So assess the performance of the antenna impedance in each of the stages is very recommended.
Okay. Then how accurate are simulations? I think we had a similar question in the morning session.
Yeah. It depends, because from the Antenna Intelligence Cloud tool it's let's say an ideal case for your device when the top layer is a continuous ground plane and there is no more components, because every device is different, so the tool cannot face all the possibilities, so all the devices that there is in the world. So the solution that the tool provides, it's a top layer solution with the antenna implemented in a continuous ground plane. So how accurate are the simulations? It depends the difference between the simulations and the real device. So if your real device has batteries underneath the antenna, components nearby the antenna, metallic casings, or parts of the casings are metallic and other parts are plastic, for example, the simulations will be very different from the real device. But the simulations, what provides you is the potential that your device has in terms of performance, which means that if you see the simulations the 80% of efficiency, this will mean this is the full potential of your device. Then if you add components that affects the antenna, you will be having less efficiency until you will go to the end device. So it depends. If you follow the design recommendations, the simulations are accurate enough to be trustable. Otherwise, it depends.
Yeah. As with any simulation, you might always run into something that doesn't exist in the simulation is a real world problem. Yeah.
Almost everything can be simulated.
Yeah. Then last question, unless we are getting in a new one. So is the documentation available in PDF or online? And I think I just saw in chat that Johan actually posted the link to the Ignion documentation. If you mean that is the correct link. If you mean the documentation of of the Nordic boards, you can find that on nordicsemi.com. If it's for the EK, you go nordicsemi.com/nf7002 EK, and you will find it. I've also seen one question in chat, and since we don't have that many, I can also answer this. That's about I think you mean DTIM 1 and 10 use cases. If you want to look at the power consumption for that one, it is also in the product spec. So if you look at the NF7002 product spec, I just looked at it. You can also just use this link. Yeah, exactly. And so the link, I tried posting it. Okay, yeah, there it is. If you look in the documentation at, which is page 35, you will see like actual, like the exact two values that you that you're looking for. And with that, we are through with all of our questions for today. So thank you very much for joining me. And thanks everyone for joining our webinar. And yeah, as always, the recording of this is going to be made available later this week, and will also include the presentations that we held today. So thanks a lot, and see you on the next one. Bye.
Thank you. Bye.